Covalent or network solids. Objective: to study the structures and properties of two covalent network solids, namely diamond and graphite. Diamond and graphite are the two naturally occurring allotropes of carbon. These allotropes differ in many properties. For example, diamond is a hard and shiny substance which does not conduct electricity. On the other hand, graphite is a soft and slippery, black-colored substance which conducts electricity. The difference in their properties arises due to different structures of these allotropes. Structure and properties of a diamond. When an electric current is passed through a diamond, the bulb does not glow. We all know that free electrons are responsible for conduction of current in solids. In a diamond, the electronic configuration of carbon is 2,4. That is, it contains 4 electrons in its outermost orbit. It shares all the 4 electrons with 4 other carbon atoms. So there are no free electrons left in the carbon atoms. Thus, the diamond is a bad conductor of electricity. When a force is applied on a diamond, it does not break. As in a diamond, carbon atoms are bonded by very strong covalent bonds to each other to form a strong tetrahedral structure. When an external force is applied, this rigid network does not allow these atoms to move from their position, and thus diamond can resist the external force. This makes the diamond very hard. In fact, it is the hardest material known to man, with a hardness of 10. Structure and properties of graphite. When an electric current is passed through a graphite rod, the bulb glows, indicating graphite as a good conductor. In graphite, out of the 4 valence electrons of carbon, it shares 3 electrons with 3 other carbon atoms, while 1 electron remains free. This forms a hexagonal structure. Many such hexagonal structures are arranged one above the other. In graphite, each carbon atom gives 1 free electron, which remains delocalized between the hexagonal structures. So, there is a large number of delocalized electrons free to move between the hexagonal structures. When electricity is passed, these delocalized electrons flow between the hexagonal layers and conduct electricity. Thus, graphite conducts electricity. Graphite is soft and slippery, thus used as a good lubricating agent. In graphite, carbon atoms form a hexagonal structure, which are held in different layers. There are weak van der Waals bonds between these layers. When an external force is applied, the van der Waals bonds cannot withstand the force, and one layer slides over the other layers. This makes graphite very soft and slippery. Summary. We have studied that in diamond, carbon atoms are bonded to form a tetrahedral structure, which makes it hard and a bad conductor of electricity. While in graphite, carbon atoms are bonded to form a hexagonal structure, which makes it soft and slippery and a good conductor of electricity.